This is May 2016, paper 2, time zone 1, question number 3, and it's a calculus question on displacement, velocity, acceleration. You're given an expression for the displacement, s equals log of 2 minus e to the negative t, and asked to find an expression for v. So we've got to find v, which is the differential of s. And this is just chain rule. Log differentiates to 1 over 2 minus e to the negative t multiplied by the differential of 2 minus e to the minus t, which is positive e to the minus t. Two minuses cancel it out. Okay, so that's part A. Oops. Part B. Find an expression for the acceleration of the particle at time t. Well, acceleration is the velocity differentiated. It's a cleverly constructed question because part A has made you use the chain rule, and part B is going to make you use the quotient rule, ideally. So we've got this function here that was supposed to be differentiating e to the minus t over 2 minus e to the minus t. So that means u is the numerator, e to the minus t, and v is the denominator, 2 minus e to the minus t. Differentiate u, minus e to the minus t, differentiate v, positive, we've already done that, positive e to the minus t. Don't need that positive really, do I? And then just stick it into the formula, v du by dt, or dv by dt there, minus u dv by dt all over v squared. So v du by dt, that's this bit, minus e to the minus t times 2 minus e to the minus t. Next bit, u dv by dt, this times this, so that's minus e to the minus t times e to the minus t all over v squared. So let's tidy that up and get it all on one line and whatnot. So that's minus e to the minus t times 2 minus e to the minus t minus e to the minus 2t. Let's expand out this bracket as well. It was originally in the yellow to give us minus 2 e to the minus t plus, oh look at that, e to the minus 2t all over, on the squared there, disaster, 2 minus e to the minus t squared. Bit of simplifying, minus 2 e to the minus t over 2 minus e to the minus t squared. That's part B, that's our expression for the velocity, the acceleration. And the last part, find the acceleration of the particle at t equals 0. Well, we've just worked out an expression for the acceleration, so all I need to do is substitute in t is 0 minus 2 e to the 0 over 2 minus e to the 0 squared. That's 2 times 1 over 1 squared is 2. 2 meters per second squared.